Hey everyone, this is Programming in Assembly. In today's program, we're going to be writing an assembly program to print the processor mode, contents, LDTR, GDTR, task register, MSW, as well as the CPU ID. Guys, so in this program, we're going to be writing or printing the processor mode. So the processor can be in 80386 had three modes, right? Real, protected, and virtual. So basically, we have to print whether our processor is x86-64 assembly, which is Intel or it can be AMD as well. So basically, you have to print whether the processor is in real or protected mode, right? That's the processor mode. Moreover, we need to print the GDTR, that is Global Descriptor Table Register Contents, as well as the LDTR or Local Descriptor Table contents. We also have the IDTR, which we are going to print, the TR, which is the task register, as well as the MSW, which is machine state word. And just for kind of an extra idea or for thrills of it, I'll be printing the CPU ID as well. This is kind of not necessary, we're just doing it for the fun of it. So this is completely optional, but these are mentioned in the question by default, even this. So let's get to it. So first of all, we'll start out with our section.data. Let's go with status message display. So we'll say start msg db. I'm putting 10 over here so that it kind of gives this tab-like effect. Processor status display. And then 0xd. This is like new line. Again, we've done this so many times. Start message EQU $ minus this. Start message. Then we'll print the exit message. This is basically needed for debugging. Okay, like is the program running correctly? Right. So yeah. Now we'll actually start writing the messages, right? So CPU mode, CPU mode 1. This is like for the mode of the processor. So if the mode of the processor is protected mode, then this message should pop up. Now here's the thing, okay? The fact that you're actually able to run this program by default means that your processor is in protected mode, right? So even if you don't write the message for real mode, which is what we will write now, I mean the real mode ka message is almost, I mean, yeah, the real mode message is never going to be shown, okay? If you are able to see the real mode message, something is seriously wrong with the processor.
Stop it.
Yeah,
Get
so
some
it's
help.
up to you if you want to write this or not. But in case your examiner checks, you should be able to tell them. So I'm writing it regardless, but just so you know, you don't actually need to write it. This is basically dead code. never going to be executed.
Okay.
Then I'll just write some generic messages, for the statements like GDTR, MSG. So I'll write these messages and I'll see you later.
An eternity later.
Alright guys, so as you can see, I've written all of these messages here. It's like repetitive, but it's like a lot of typing. So I just skip past it. Now we'll move to section.bss, right, where we have basically all of these variables. So I'll just say GDTR content. It's too long, but whatever. GDTR save, we need LDTR save, we need IDTR save, we need TR save or TR content. Then need MSW save, MSW content, right? Then I'm also taking D4 save, or this is like we're going to use this for internal purposes, which I'll explain you later. And I'm also going to do vendor string, which we'll be using for CPUID. So that is something else. All right. I'll just put resv4 in all of these. So that should be pretty easy. I just go click Alt and click in front of all of these. And yeah, okay, this is not supposed to have resv. So all of these are now resv4. Actually, GDTR needs to be 6. So LDTR can be 2. So IDTR also needs to be 6 because GDTR and IDTR are 48-bit registers, right? So they need 6 bytes. 48 bits is 6 bytes. So yeah, and TR is just 2, just like LDTR. MSW and D4 save, which we're going to use, are going to be 4 bytes each. Then we have a standard macro read write, right? Macro RW with 3 arguments. First one is move RAX, comma 1 for the mode read or write, move RDI, comma number 1 for the file handler, move RSI, comma 2 for a variable which we have to print, RDX. The third one for the length of the variable, syscall to YAML. No, that joke is old now. And end macro RW. We name the macro RW. There. Actually, you don't need to. Yeah, never mind. End macro. That's all. Now, yeah, in the section dot text, here we're going to like define the logic as usual. Wait, I forgot global start. Yeah. Okay. Now, here our flow is going to be, first of all, we'll like print the start. What was the first message? Start message. Okay. Start message and start message length. Okay, so we'll print that. Now we have to actually save the MSW. So we'll save MSW and EAX. Now the reason why I'm using EAX over here instead of RAX is, well, because MSW is 32-bit regardless. So even if I use RAX, it will use 32 bits only. Yeah, then I'll have to actually bit test, right? So BT is the instruction to bit test, which basically kind of goes one by one on the bits. So if I can like show you, this is your EAX, and there are like bits right from here. So what bit test is going to do is it will test. Okay, so the bits are numbered like this from left to right. So 1, 2, 3, 4, 5, and so on and so forth. Obviously, EX will be 32, so either 31 rahega. 31 will be here. And what this will do is, if I say test the 0th bit, it will test this bit. If I say test the third bit, it will test the bit is 0, then the carry flag or CF will be reset. And if perchance the bit is 1, so say like the sixth bit over here is 1, then in this case the carry flag will be set to 1, right? So on basis of that, you can basically tell कि अच्छा ऐसा हो रहा है. So BTEAX is 0, and then if jump if carry, right? So jump if carry protect or prot I'll say. Yeah, protect. Acha, protect is a keyword, so you'll say protect. And if it is 0, which would mean that the computer is in this mode, real mode,
या कुछ ना कुछ तो गड़बड़ जरूर है.
we'll print the necessary message, right? CPU mode to length, right? And obviously, if this is the case, I would really like to exit. Yeah, so we'll write a macro, exit macro as well. We'll use this to exit from the program over here. Now we go to the protected label. So this is where we'll be printing if the computer is in protected mode, which if you're running this program on your computer, it will 100% be in protected. We've like done the protected mode thing, correct? Now we need to do is save all the tables or the GDTR, LDTR, IDTR, TR ke contents. We need to save them. So that's what we are going to do. What I'm going to do is the command for saving GDTR is sgdt, and I'll put contents of GDTR content. Now similarly there is for SLDT, and you can put LDTR content. Same for SIDT, there is a command. This basically saves the contents of that particular register into your given memory location. And STR is for saving task register. So TR, oh, I messed up, TR content there. And SMSW, it saves the machine state word MSW content. Yeah. Now here's the thing. Like we discussed before, there was a thing, right, for displaying CPU data. But CPU data is a little bit complex, so we'll do it later. It will also need like a process, a procedure and all. So yeah, let's do that later. It will be smart to do that later. GDTR contents. Over here, this is the place where we write a bunch of commands to save GDTR content. There's nothing like unique or rocket science-ish here. It's just typing till we get the answer. GDTR content plus 4. So we'll basically call a procedure over here called this 4, and over here we'll call move bx, comma GDTR save, or content in our case, plus 2, and call display 4 again, rw Okay, VX GDTR content. Basically, what I was trying to say is that dis4 is our display method only. It's just that it's not going to display all the bits, all the 64 bits. It's only going to display 2 bytes. That's why I've named it differently. Anyways, right, so now we'll have to display after GDTR. We have the LDTR and IDTR contents. Now here's the thing, okay. For LDTR, LDTR is what? 2 bytes. So we don't need itna cust for that, right? Here, I'll just write LDTR. So what we do here is we RW01, comma, DTR content, comma, LDTR message. After LDTR, we need to display IDTR contents as well. So let's do those. Right. So RW, this is actually the same as GDTR. Like I was saying, IDTR and GDTR have like the same lengths, right? So what we have to do is just take GDTR, okay, no, take GDTR idhar and just turn it to IDTR. See, IDTR, IDTR here, IDTR here, IDTR here, done. Oh, there's a full stop over here. See, I do mistakes like these and then it takes me like 30 minutes extra to debug this because later you're not able to find these out. So yeah, guys, learn from my mistakes. Don't code in a hurry. Be cool, calm, and composed while you code. Wisdom, bro. You should probably consider subscribing, getting wiser every day by watching my channel. Now we'll display the TR contents. So TR contents are again same as LDTR. So you can just keep on copy and pasting this idhar ऊपर का ही. Cause well, let's just see TR message. Nee, what?
Oh, no, 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 no.
They ask you how you are, you just have to say that you're fine when you're not really.
Yeah, we messed up. Guys, idhar it should be LDTR message and LDTR message length. RW, this is done. TR ka contents we have shown. Now we need to display MSW contents. For MSW contents, we'll first of all, like everything else, we'll write the MSW content message with MSW message length. Okay, we did it again, guys. We will write the MSW message with message length. Then we'll move PX the MSW content plus 2. By the way, this type of indexing or addressing, sorry, is known as displacement addressing. Because what we are essentially doing is taking the address MSW content and we are adding 2 to it. So it's like displacing the current address, right? That's why it's actually called that. And we call display 4 SP4. For now, I won't do the CPUID. We'll just first put a quick exit here. Exit. And before exit, we'll write our RW01 exit message and exit message length. Yeah. Now is the time for the display or disp4. So now we'll actually get to know what is the suspense. Disk 4, move RDI to D4 save, which is where final answer is going to be. So the RDI is pointing at the final answer. We'll first move RCX or the counter to 4. RCX is a counter, right? Then what we'll do is we'll have a label, I don't know, stop 1, and over here we'll basically do everything that we have like been doing on in our programs for display. So we'll do rotate left BX, we'll move PX to AX, or actually we'll move BL to AL, then we'll AND AL with 0FH to mask the tens place. So like the tens place is now going to be 0, only the units place is going to be visible. Then we compare the units place in AL with 09H. After doing that, we'll like see na ki agar it is greater or smaller. That's what we need to see. J if it is lesser than or equal to. So add L comma 30H, and we'll do add L comma 7H over here. This is pretty much done now, guys. Like now we'll just move RDI, like move AL to RDI, because that's where D4 save is. We'll increase RDI so that next memory location is available. We'll loop to stop 1, write it. So read write 01 D4 save 4, because it's like a 4-bit thing. That's why our RCX is also 4, and we'll do ret. We can probably run the program to check if it's working or not. See, so GDTR message contents, LDTR contents, IDTR, TR, MSW. All of these contents are here, and I'll put a new line after this as well, so that the program is more presentable. Actually, I'll put a new line after every message. We'll do the bonus part. You can probably stop watching now. If you want to learn like more stuff, welcome to keep watching. This CPUID stuff is going to be quick only. Just going to be like a few commands here and there. What I'm going to basically do is I'm going to print the vendor string over here. If you don't know what a vendor string is basically a predefined string which every manufacturer codes in their processor. So that is like by default. Okay, so for Intel it will be genuine Intel. For AMD it will be, I guess, authentic AMD. And if your PCs are rare now, there are sometimes where Intel or AMD will add like intentional errors or Easter eggs in their vendor string. You can like probably find out if your PC is like super rare or your model is super rare. The CPUID command, basically you can find this in the lab manual. Okay, for Intel, I said lab manual, it's the user manual. Intel's website page it's published, and this is common for AMD processors as well. So if you have an AMD processor, this will 100% work. And by the way, you don't need to actually even convert this to ASCII hex. That's why we call it a string, right? It's actually already in ASCII hex characters. So you don't need to actually do that. Yeah, and this is pretty much it. Input the CPU status message, CPU start and CPU start length. We need a new line as well. Crowd it up.
Emotional damage.
What did I do now? I did an oopsie. Okay, this is working. See, CPUID, genuine Intel, and all of this. I'll just add new lines. There. This is it, guys. This program was like pretty small in length as well, and it's pretty easy. There's not like a lot of stuff you can do or have to do in this. If you get this for practicals, you're like a lucky guy, I'd say. That's all. Thanks for watching. See you later.